Since the days of Telford, the bulk of the England to Scotland traffic has travelled the route from Carlisle to Glasgow. Over the past 15 years, major improvements have been made to this roadway to cope with the considerable increase in traffic. Although these improvements produced a satisfactory route from the borders to the outskirts of the Lanarkshire industrial belt, it became obvious that here, in this densely populated area, similar improvements would be inadequate. To maintain the speedy flow of traffic through the area and assist industrial progress, a special road would be required. Early in 1960, a full-scale traffic survey centred on Hamilton and based on the growth of traffic into the 1980s confirmed the need for a motorway. In 1961, preliminary planning and design were carried out on contoured plans obtained from a comprehensive aerial survey of the areas likely to be affected. While planning proceeded in the design office, site investigations were carried out. An extensive series of trial borings was made. From the rock and clay samples obtained, the engineers were able to prepare a detailed record of the type of ground which would be encountered along the line of the motorway. The mass of information obtained from the fundamental surveys was then analysed and the final design prepared. The motorway was designed on the flowing alignment principle. This principle depends upon the coordination of horizontal and vertical curves and ensures a pleasing and safe road layout. Extensive use was made of models to check that safety, sighting and landscaping requirements were met. The chosen route generally follows the valley of the Clyde to the east of the existing trunk road A74. From Blackwood, the motorway line bypasses Lark Hall, crosses the rivers Avon and Clyde between Hamilton and Motherwell, and after bypassing Uddingston, rejoins the A74 at Maryville. Construction of the motorway began in June 1964. The contractor's first operation was to clear the site of all obstacles to make way for the earth-moving machines. Simple but effective tree felling methods coupled with specialized log handling equipment quickly cleared woodland areas. Very few buildings were affected, but some families had to be disturbed and their homes demolished. Because of the undulating nature of the countryside, earthworks on a major scale were required, with extensive excavations in cuttings and the formation of large embankments. To ensure the stability of the roadway, vast quantities of peat, silty clay and other unsuitable material were removed and replaced with suitable free draining material. Although the excavated material was unsuitable for road construction purposes, it was used to infill and reclaim marshy ground for future agricultural use. Almost 9 million cubic yards of both suitable and unsuitable clay had to be shifted in less than 3 years. This is earth moving on a large scale. To accomplish such bulk excavation successfully, an organization of the highest order was required, employing all forms of up-to-date muck shifting equipment. Adverse weather and the generally difficult conditions severely taxed the capabilities of even the finest plant, but cooperation and mutual assistance at all levels maintained steady round-the-clock working. By moving some 14 to 18 tons of muck at a time, machines like these scrapers near Bothwell soon transformed the landscape, and the eventual profile of the roadway began to take shape. Apart from soft excavation, rock of variable texture and composition had to be excavated from the deep cuttings. The rock conformed generally with the information obtained from the site investigations, but there were areas where it had been badly fractured due to the settlement of old uncharted coal workings. Fortunately, the workings were concentrated in one area, but being close to the road formation, they rendered the roadway liable to future subsidence. So they had to be traced, broken out and backfilled. This operation increased the volume of rock excavated beyond the estimated amount. However, good use was made of the excavated rock elsewhere on the site. On a project of this magnitude, it is essential that the movement of materials is carried out speedily and efficiently. The huge fleet of dump trucks required presented too great a burden for the already congested public road system. The solution was fast haul roads built within the line of the eventual motorway, permitting construction traffic to travel at speeds of up to 50 miles an hour. In the Hamilton Low Parks, mineral subsidence over the years had lowered the ground level by about 17 feet and made the area susceptible to flooding. To prevent erosion, the base layers of the motorway embankment in this area were built of excavated rock. Piled foundations were a necessary feature of bridge construction. Here at the A723 interchange, steel-cased cast in situ piles were used. The stepped casings of these 70-ton and 100-ton capacity piles were assembled on site from 10 and 12-foot sections. In its final length, the casing is quite flexible. Before driving, however, a stepped steel mandrel is fitted inside the casing. This provides the necessary support and distributes the pile driving force to each section during driving. Almost 1,200 piles of this type were required. On the northern section of the project, driven concrete cased cast-in-situ piles were used at Great Bridge and at the sites of bridges designed to carry side roads over or under the motorway. With this form of pile, the casing was constructed in short lengths of reinforced concrete tube. To provide adequate load-bearing capacity for the bridge foundations, many of the piles had to be driven to a rake. Careful checks were kept on the bearing capacity of completed piles by load tests on selected piles at each bridge site. Board piles were used at isolated bridge sites where fewer piles were required, and restricted working space favored the use of lighter and more manageable equipment. The hydraulically operated Taywood Pilemaster was used to install protective sheet piling at the site of Powburn Toll Bridge. This allowed the excavations for the bridge foundations to be carried out with the minimum interference to adjacent properties. To permit uninterrupted flow of motorway traffic through the maze of existing roads, railways and rivers, and to make adequate provision for vehicles and pedestrians at interchanges, 42 bridges of varying designs were required. For safety and aesthetic reasons, every effort was made to keep bridge supports to a minimum, but the economic aspect generally prevailed, and the majority of the structures were of multi-span design, built of cast-in-situ reinforced concrete. The design of all bridges, apart from some minor accommodation bridges and footbridges, was based on the Ministry of Transport standard HB loading criteria. The river crossing of the Clyde near Bothwell demanded a different treatment. To carry the motorway over this major obstacle, it was necessary to design Rafe Bridge in long spans of composite steel deck. This meant the use of deep box-section steel girders as the main structural elements of the deck. These 140 feet long girders were composed of large prefabricated units transported to site where they were welded together ready for launching. Launching the beams was a tricky operation, and to dovetail into the main construction program, it was necessary to proceed regardless of weather. The first section was launched in winter, adding to the difficulties of the construction crew. But when the second section was pulled across the river, conditions were more favorable. Throughout, a high degree of precision was maintained to ensure correct alignment and positioning on piers and seatings. An electric train passing through Uddingston Junction every 20 minutes imposed severe restrictions on the design and construction of the bridge to carry the motorway over the railway. The obvious answer was precast construction, the structural deck being formed of pre-stressed concrete beams. The pre-tension beams, manufactured in a Scottish precast concrete works and ranging in length from 30 to 40 feet, were easily and quickly lifted and placed in position over the tracks onto abutment and pier seatings. At the north end of the project, the two-level bridge at Maryville is the main feature in the compact layout of the interchange linking M74 with the projected M73. Great separated directional interchanges require extensive areas of land, and to simplify the construction of the connecting roads at A723, the course of the River Avon had to be altered. Once the river spans of the Avon Bridge had been completed, the river was diverted into its new channel and the old river bed backfilled. During the winter seasons of 1964 and 1965, construction work more or less came to a standstill due to adverse weather. Extensive flooding was experienced, particularly in the low-lying areas around the River Avon and the Hamilton Low Parks adjacent to the River Clyde. At the design stage, an hydraulic model investigation had indicated that flooding on this scale could occur. Information obtained from the model analysis was used, however, in the determination of economic spans for the Avon and Wraith bridges, and of safe levels for motorway and slip road embankments. The flooding caused serious delays. Temporary bridge works were extensively damaged and plant marooned. Although temporary works were adversely affected, the permanent embankment with its rock-filled toe easily withstood the eroding effects of the floodwater. When the floodwater subsided, damage to existing riverbanks was examined, and to minimize the effect of future flooding, the Clyde and the Avon were cleared of obstacles. Existing gravel and shingle beds were removed or regraded to provide better hydraulic channels. Where necessary, and particularly along the Avon diversion channel, steel sheet piling was driven to act as a protection against future erosion. Although almost 5 million cubic yards of good structural material was obtained from the motorway cuttings, in order to complete the embankments, another 4.5 million cubic yards had to be found elsewhere. One of the major sources of borrow was an extensive tip of steelworks waste which lay close to the line of the motorway near Motherwell. Coupled with local sources of colliery blaze, this material provided the balance required. The approach embankments to bridges were carefully composed of specially selected, well-compacted granular materials to safeguard against differential settlement occurring in the final road surfacing. In some areas of the northern section of the works, the depth of unsuitable material below embankments rendered its total removal an economic and practical impossibility. There, embankments were built of pulverized fuel ash, the waste product of coal-fired electricity generating stations. This material is ideal for such situations, for being lighter than clay or blaze, it requires less support from the underlying strata. To ensure adequate compaction and structural soundness, even the highest embankments, some as high as 60 feet, were built in 12-inch thick layers, each layer being thoroughly rolled and graded before the next layer was spread. At the same time, side slopes were carefully graded and trimmed to their final shape. Not always to straight geometric lines, but often to varying slopes and contoured curves, so that the completed roadway would better merge with the surrounding landscape. The design of both flexible and rigid pavement constructions was based on Road Note 29 of the Road Research Laboratory. After general earthworks were completed, the formation level of the road was graded to line and level and sub-base laid. The sub-base was composed of 2 layers, each 6 inches compacted thickness. When the lower layer of burned colliery blaze or steelworks waste had been laid and compacted, the upper layer of frost-resistant processed slag was spread, graded, and rolled to profile. To assess its performance under Scottish conditions, a 2-mile stretch of rigid concrete pavement was built using the Guntert und Zimmermann slip-form paver, the first use of this machine in Scotland. The 11-inch thick by 27 feet wide slab of air-entrained reinforced concrete was laid on a polythene membrane in one operation, without the use of side forms, and at an approximate rate of 200 feet per hour. Mechanical brushes were used to texture the road surface and provide good road-holding qualities. Finally, the surface was sealed with a curing membrane, sprayed on automatically. The riding quality of the completed pavement was checked by the use of a profilometer. Carriageway construction in the main was carried out in flexible composite base construction. The lower base of 7-inch thick lean concrete with an average aggregate to cement ratio of 18:1 was laid on the prepared sub-base by rubber-tired Blow-Knox mechanical spreaders and compacted to an average density of 140 pounds per cubic foot with vibrating and 10-ton smooth-wheeled rollers. To complete the flexible base, the lean concrete was capped with a 3-inch thick layer of dense bitumen macadam. The roadway was now almost ready to receive its final surfacing of 4-inch thick, 2-course, hot-rolled asphalt. At the A71 and A723 junctions, however, it had been decided to provide under-road heating on certain of the slip road connections. Mats of expanded metal were laid across the full running surface of the carriageway, secured in position so that the final asphalt surfacing could be machine laid, and connected to a low-voltage electricity supply. In winter, the heated mats will keep these sections of carriageway free of snow and ice. The surfacing of the carriageways was completed with the laying of a 1.5-inch thick wearing course of hot-rolled asphalt. The final appearance, safety and riding quality of the running surface was attained by spreading and rolling in white Creetown granite pre-coated chippings to provide a high non-skid quality. On the 2nd of December 1966, a cold and blustery day, Mr. Peyton of Babty, Shaw and Morton invited the Secretary of State for Scotland, the Right Honourable William Ross MP, to officially open the first stage of M74. Mr. Ross praised the contractors and the consulting engineers for their combined efforts in completing, on time, the first stage of what he described as the kind of road we need, essential to the carrying of commercial traffic if we are going to support the growth of new and even greater industry. This great new road, he said, is going to help meet the great new needs of Scotland. M74 is going to provide an important and major link in the motorway system being constructed in central Scotland. In the short time it takes you to travel the length of the M74, you may not be fully aware of the intricacies of flowing alignment, the aesthetics of bridge design, and the many precautions incorporated for your safety. But when you realize that you have traveled 15 miles in as many minutes without discomfort, congestion or monotony, perhaps you will then appreciate the skill of the engineers and the efforts of the builders.